day everyone. My name is Richard Angelson from the Bachelor of Science and Civil Engineering, and for today we will answer a sample problem involving torque. The problem is, a boy is trying to open a stock door. He pushes it at a point 0.83 meters from the hinges with a 250 Newton force directed 20 degrees away from being perpendicular to the door. The hinges are a natural pivot point. Determine the torque does the boy exert. How could he exert more torque? So we will answer that problem. In this problem, we are tasked to find two unknowns. The first one is to determine the torque does the boy exert. The second one is how could the boy exert more torque when he opened the stock door. We also have certain given values such as the distance whereas the force is being exerted with respect to the hinge, the magnitude of the force exerted, and its respective angle with respect to the perpendicular line in the radial line. So by analyzing, we can translate this problem to this diagram. Whereas it is the hinge, itong bilog na to is denoted as the hinge or the pivoting point. The broken lines are the radial line. This arrow represents the 90 degrees angle or perpendicular line. And this arrow represents whereas the force is being exerted. At yung magnitude niya ng force na yun is 250 Newton. And the 20 degrees that we saw in here represents yung angle ng force na inexert with respect dun sa perpendicular line. The 0.83 meters represent the distance wherein the force, which is ito, is exerted with respect dun sa pivoting point. So, in this problem, we will utilize this formula, which is torque is equals to radius multiplied by perpendicular force. So, by analyzing, in order for us to utilize this formula, we need to find perpendicular force first. So, to do that, we will derive a formula in perpendicular force, and ito yon. Now, yung perpendicular force is equals to F cos 20 degrees. 20 degrees since 20 degrees yung angle na to. At by going back, we should also know that yung gagamitin nating radius dito is yung 0.83 meters. Therefore, kailangan natin ng perpendicular force para ma-solve yung problem na to. At to do that, we need to find the component of this force perpendicular to the radial line. Kaya natin gagawin ito. So, by substituting the values, alam natin na yung force stated in the problem equates to 250 Newton. At yung angle is 20 degrees cosine dahil it deals with a certain axis. At by calculating, we will arrive at a perpendicular force that is 234.92 Newton. So after finding the perpendicular force, we can finally plug in the values since the radius that we will utilize is 0.83 meters. We will just substitute it into the equation. And magiging ganito na yung itsura niya. Sa-substitute lang din natin yung perpendicular force. And by calculating, we will get 194.98 nanometer. So, ito yung na-exert na force ng boy given na yung layo niya nung pag-exert dun sa hinge is 0.83 meters at merong certain angle na 20 meters yung 250 Newton na force na kanyang in-exert. So sagutin na natin yung second question. How could the boy exert more torque? So it is very simple because the farther where we exert the force in the pivoting point, mas nagiging madali yung pag-exert ng torque. So, yung probability na mas madaling ma-open yung door is tumataas as long as palayo yung point kung saan natin itutulak yung door. Which means na kung ginawa niyang 0.99 meters to, is mas tataas yung torque na ma-exert niya. We should also take note that may factor din yung angle kung saan niya ine-exert yung kanyang force, dahil kung in-exert niya yung force na instead of 20 degrees angle, kung 90 degree angle ang ginawa niya, which is perpendicular nga dun sa radial line, is mas tataas yung torque na mabibigay niya. Mas madaling ma-open yung stock door. At foremost, huwag nating kalimutan yung mismong output. If we increase the output or yung ibinibigay niyang force with complementary dun sa paglayo niya doon sa pivoting point sa pag-exert ng force, at yung pag-exert ng mataas na force kesa sa 250 Newton na perpendicular, is definitely it will increase the torque that the boy can apply. So that is the answer in the second question.